Rocket launches are almost always a spectacular thing to see, be it Starlink or Artemis, an Electron or mighty Saturn V. All of them are beautiful in their own right. However, have you ever wondered where they launch from? Can't just have a launch pad in central London? Huh, quite loud. Now, it's not just that the noise would be, well, loud, it can also be destructive. Noise can hurt, both humans and buildings. On the Saturn V's first launch, Apollo 4, 5 F-1 engines and the noise shook the ground, lifting a beast into the skies. And noise is a form of power. We hear sound because it vibrates the molecule of the medium it travels through. A rocket launch is concentrated in the low to mid frequencies, which happen to be the bad ones that destroy stuff and humans. Yay! Okay, but that's solved fairly easily, right? Just don't launch in a city. It's actually not as easy as that. What about the rocket, the launch tower, the pad? During launches, the pad is sprayed with tons of water. That's why the moment between the engines firing and actual liftoff produces smoke, but the smoke doesn't follow the rocket upwards. It is water vapor from what's known as a water deluge system. However, if the trail of smoke actually does follow the rocket up, it's most likely a rocket that uses solid fuel. A water deluge system is also called a sound suppression system, which describes well what it does. It not only protects the launch pad, but the rocket itself, because the noise could potentially bounce off the pad and inflict damage on the vehicle. So the enormous amounts of water dissipate the sound. Wait, where were we? Seems we went to tangent town there. Well, where do rockets launch from? Let's take 4 different examples. Guyana Space Center, located in French Guyana, which is part of France? In South America? Not going on a tangent again. It has 3 launch pads, plus one that just retired, so there's, as I mentioned, ENA 3's launch zone. With the last flight of the Ariane 5 in July 2023, this is no longer used. For now. Same kinda goes for the ZLS, the Soyuz launch zone. Yes, sorry, these acronyms are in French, I'm sorry. Soyuz launches from Kourou, which is where the spaceport is, have been suspended due to political war invasion, usual reason why you don't watch the news. The ZLV launch facility is used for Vega, whatever. ESA's and Arianespace's small rocket, being able to lift about 1.5 tons to sun-synchronous orbit. And of course, ENA 4 for Ariane 6, the rocket to replace Ariane 5. There's also Baikonur Cosmodrome, which is actually in Kazakhstan but operated by Russia, being the place where the first human to ever visit space, Yuri Gagarin, launched from aboard Vostok 1, as well as countless Soyuz launches to the International Space Station. For Baikonur Site 1 specifically, nicknamed Gagarin style, there's a lot more pads here. Site 31 was originally a backup option to launch a Soyuz spacecraft, with the same name as the rocket, so don't get confused because the Soyuz rocket also launches payloads and the Soyuz spacecraft. Site 31 then became the primary launch site when the Soyuz rocket upgraded from the Soyuz FG to Soyuz 2, which couldn't launch from Site 1 because planned upgrades just didn't happen. Site 81 consists of 2 pads. Area 24 was originally used for Proton, but then quietly got abandoned, leaving only Site 200 for Proton, because Area 23 is also inactive and has been for much longer. Site 200 has 2 pads, one is inactive, but the other one is the only launch site left for Proton. And there's a lot more. It's just too much, and most of them are inactive anyway, so next. And there's 2 places in the US, those being the famous Kennedy Space Center, which is got together with the nearby Cape Canaveral Space Force Base, with a lot of pads. And while most currently aren't used, there still remain many that are used, such as Launch Complex 39 in the Space Center, having 3 pads, 39A, leased by SpaceX for launches of the Falcon 9 and Falcon Heavy rockets, but historically launched almost all Saturn V missions. And together with 39B, now used for the SLS, they both were used for countless shuttle launches when the vehicles still flew, and the tiny 39C came in 2015 for small lift launches. It's actually within the parameter of the 39B. There's plenty more pads in the Space Force base. There's Space Launch Complex 37. There's 2 pads, 37A, which has never been used, and 37B, which is used to launch the Delta IV and Delta IV Heavy rockets by ULA. However, that rocket will retire in 2024, with 1 launch left from this very pad. Now there's also the Vulcan Center, which will replace the Atlas V. This one, both Vulcan and Atlas V, launched with Space Launch Complex 41, and Space Launch Complex 40 is actually slick, SLC slick, used also for SpaceX's Falcon 9. However, it doesn't have any means to get crew into the vehicle, therefore it's only used for uncrewed launches, unlike 39A. Although there are plans to change that. Finally, there's also Launch Complex 16, currently used by Relativity Space. And actually there's LC-36, which will be used by Blue Origin for their up-and-coming rocket, the New Glenn. Vandenberg Space Force Base is the other US launch site, which has Slick 6, originally meant for things like the Manned Orbit Ring Laboratory, and later supposed to be the US West Coast launch site for the Space Shuttle, both of which got cancelled. The Challenger disaster grounded the shuttle fleet, ending the idea of shuttle launches from the US West Coast for good, before shuttle could ever launch from Vandenberg. Slick 6 was then reconfigured again for the Delta IV family of rockets. The last flight of a Delta IV Heavy will however launch from Cape Canaveral, or might already has, depending on when you are watching this. Atlas V also launches from here, launching from Slick 3 East. Slick 3 West having been demolished. It was used in the early development of Falcon 1, but SpaceX then switched to Slick 4 East for Falcon 9. In fact, the main flight of Falcon 9 V1.1, which significantly increased the Falcon 9's capabilities, was from Vandenberg. Slick 4 West is used as a landing zone. The real question, however, is why? Why have these sites been chosen? To explain that, you need to know 3 things. First of all, the Earth is a spinning ball, and flat earthers aren't gonna like this. Rockets don't just go up, and rockets store empty fuel tanks. Let's start with the first one. The Earth is a rotating globe. Well, actually... Shut up. The Earth is a spinning globe, still, but because the Earth is a globe, it doesn't spin everywhere with the same speed. At the equator, Earth's rotation is at its fastest, with 1,600 kilometers an hour. You don't notice this because g-forces aren't speed, but changes in speed. Like, if you're traveling in a spaceship and the spaceship doesn't accelerate, you're moving at the same speed and therefore you're weightless. But when it starts to accelerate, suddenly the floor pushes into you and boom, g-forces. Once the engine is shut off, you still travel faster than before, but you go back to 0g as you're both moving faster now. Now, as I said, Earth does actually rotate slower the further you are from the equator, but you're not gonna be able to feel the difference at a human scale and a human speed. But why does the rotation and speed differ? Okay, now look at this. This is the southern hemisphere. The South Pole is in the center. Now if you start spinning the Earth, you'll notice that the equator has to travel further than the pole in the same time. Same goes for the northern hemisphere, obviously. This causes what's known as the Coriolis effect. If you throw a ball from Cameroon to Germany, you will see it landing to the right of where you aimed it. That's because the Earth is spinning slower and your ball was thrown not only with the velocity northwards to reach Germany, but also the velocity eastwards from you rotating. This velocity still exists in Germany, but is much slower than in Cameroon. Imagine sitting on a spinning disc and tossing a ball across it. It looks like the trajectory of the ball curves, but if you stand beside the spinning disc, it isn't curved. You're the one moving. It is part of the reason for trade winds and affect a whole bunch of weather phenomena. Confused yet? Great! Continuing with weather, you can see this effect much stronger on Jupiter, because it spins way faster. You see these belts? They're caused by the Coriolis effect. The parts in between the belts are active storm regions. Jupiter's a windy boy. Here, look at that storm. That's a storm. Essentially, this means, back on topic, that rockets launching closer to the equator get an extra boost, because they take the extra speed from Earth's spinning. Rockets don't just go up. If you go up, you'll fall back down. Throw a ball straight upwards and it'll land on your head, or at least near you. Throw a ball straight forwards and it won't go up at all, just downrange. If you throw a ball fast enough that it goes all the way around the Earth, that would be in orbit. However, the air still slows it down and it would probably burn up due to the air compressing in front of it, which makes everything super hot. So, rockets first go up to get high enough to escape the atmosphere, which means they don't have to deal with the friction slowing you down and the compression heating you up, but then start to turn horizontal, usually east, as I said, getting its speed boost, until they're fast enough to fall around the whole Earth. This isn't actually a sudden 90-degree turn. Once they leave the atmosphere, it's actually a long, elegant curve. And rockets throw away empty fuel tanks. That's what's known as staging. The first stage lights its engines, fires until the fuel tanks are empty, detaches, and reveals another stage with another engine or multiple engines. These engines have their own fuel tanks. This isn't the only way of how staging works. You can also have extra stages attached to the side. Staging that involves such boosters is known as parallel staging, compared to the normal series staging. The Delta II has solid rocket boosters attached to the side of its main stage. The Delta IV Heavy has two gigantic boosters attached to the side of it. And once stages are detached, they fall back down. SpaceX is actually landing these to reuse them. The Falcon 9 rocket lands their first stages back on Earth, usually on a small swinging landing pad, a drone ship, or back near the launch pad in a maneuver known as return to launch site. Same goes for Falcon Heavy, basically a Falcon 9 with two extra first stages attached to the side of the core. Rocket Lab's Neutron is a rocket in development and is also planning on doing this. But the matter is, rocket stages fall back down, controlled or not. Looking back on our map, it seems clear why these locations have been chosen. Almost. Well, first off, Kennedy Space Center and Cape Canaveral Space Force Base are on the east coast of the US to be able to launch rockets eastward, and not have the stages fall into inhabited areas, while also being close to the equator. Same goes for the Guyana Spaceport, being situated in a small part of France, even closer to the equator, while also having water to the east. But what about Baikonur and Vandenberg? First off, Baikonur is situated in Kazakhstan because back when the Soviet Union was a thing, they wanted to go with a launch site relatively far south that has sparsely populated areas within its flight path, and that area then became independent. Vandenberg, however, is different because the United States already has a well-situated East Coast launch site. Vandenberg is used for polar orbits. By going east gives you a speed boost and also nicely aligns you with the moon and other interplanetary destinations. If you go north or south, you'll see more of the Earth. By utilizing the Earth's rotation, you can see targets further north or south using your own movements, while Earth's rotation shows you targets further east or west. And from Vandenberg, you can go south really nicely. Please note that this is far from a completed list of launch sites or launch vehicles, but I hope that this gives you a good overview that helps explain why certain places are better to launch from than others, and helps explain other launch sites that may are listed here as well. Thank you very much for watching. If you enjoy such content, a like and a subscribe is very welcome. See you next time. Which significantly increased the Falcon 9's capabilities was from Vandenberg.